All right, folks, Bass Action back in action here. On this page of notes, we're going to continue our discussion of characteristics of polynomial functions, and we are going to incorporate some new notation different than what you would have had in your Algebra 2 classes. So let's jump into step number 4 is understanding power functions, okay? So power functions, we can really think of these as some parent functions. These are almost like our parent functions for some of our polynomials. So x squared, of course, we're familiar with what an x squared looks like, so we can easily do a quick little sketch of our quadratic and just sketching that one in here really quickly. The power functions we'll refer to in just a little bit to help us with our end behavior discussion. Now, next would be our cubic. We, of course, are familiar with our cubic, so we can see this as that little snake right there. Now, what we want to understand is how our x squared connects with what we would call our quartic here. So how are these similar? And they are certainly related to each other. So the only real difference between our x squared and our x to the fourth that we could see if we tried to actually graph this, if we draw this in, what happens is that along the bottom here, it's not so much that it actually touches all these places right here. What we're really seeing is that this part of the graph is flatter than on the x squared. Because what happens is that its rate of change, the rate that it starts to increase, is much slower here, down here on the x to the fourth than it is on our quadratic. A similar thing will happen when we look at our x to the fifth power function, and we can kind of start off with some of our same points, but the same thing's going to happen. It's going to increase at a much slower rate before it actually goes up. And we're not really able with our hands to write it and make it look much better, but we really just want to understand that it also is going to be flatter than the x cubed. Now, the really important part on this page is understanding our end behavior. This end behavior is very, very crucial because it's going to allow us to do almost all of our sketches. So some of this is going to be very, very familiar to you, and then our limit notation will be new. So let's talk about the parts that are the same, things that you already know. So what we're going to look at is that we're going to look at our highest degree, and we're going to look at the sign of the leading coefficient. So, for example, if I think about my highest degree being odd, okay, and my simplest polynomial that has an odd degree is going to be a line. So if I think of a line with a positive slope, okay, then that line would look something like this. What that allows me to understand then is that the end behavior, it should point up over here and it should point down here, because as I connect those, it would create a positive sloping line. Conversely, if I have a odd degree and I have my odd degree, but instead I have a negative leading coefficient, then I'm going to imagine a negative sloping line. So I can fill in that end behavior. And this is the part that should seem familiar to you from your Algebra 2 courses. Now from here, what I know that I can do is my graph doesn't necessarily truly look like a line. It could be some crazy smooth curve that makes lots and lots of turns depending on its degree. And same thing here, it could make lots and lots and lots of turns depending on its degree. But ultimately, the beginning and the end should look like that. Now, what this is going to let us do is we can then take this behavior, these red arrows, and convert this to some new notation. And what this new notation here is saying is that as my x values go to negative infinity, so as the x values go to negative infinity, what's happening with the y's? oh, they're going to also to negative infinity. And as my x values are going to positive infinity, what's happening with the y's? They're going to positive infinity. We can look at it for the next one as well. As x goes to negative infinity, I can see the y values are going to positive infinity. And as my x goes to positive infinity, the y's are going to negative infinity. And there is one small little typo here. Right here, that should have said a plus, so you might want to fix that because otherwise your notes aren't going to totally make all the sense that you want them to make. So write yourself a little note here. Let's fix that. So let's look at our even degrees. So if we have an even degree, our simplest polynomial with a even degree would be a parabola, our degree 2. So we're going to imagine a parabola with a positive leading coefficient. So what would that look like? It would be a nice upward turning parabola. So what you would have done in your Algebra 2 courses is you would have said the end behaviors looked like this. Of course, our parabola with our negative leading coefficient would have looked like this. So its end behavior would have been down and down. Now, of course, for any general polynomial, they're not just going to be parabolas. They might make lots and lots and lots of turns, but eventually they need to connect up with that particular end behavior. So who knows how many little turns we have? It all depends on the function. But now we can go through and we can actually understand our new notation. As x goes to negative infinity, y is going to positive infinity. As x goes to positive infinity, y is going to positive infinity. So now we can see those are the same. And as x goes to negative infinity, y goes to negative infinity. And as x goes to positive infinity, y goes to negative infinity. All right then. So let's look at some applications of this. So first thing that we want to do is we want to understand our degrees and we want to understand our leading coefficients. So we can find each of our degrees, and what matters the most on those degrees for us is whether they are even or odd. So that's the first thing we're going to think about. So our x cubed, of course, has an odd degree. Our x to the 5th has an odd degree. Our x squared is even. And our x to the 4th is even. Now we want to also look at the sign of the leading coefficient. So we're going to look at these signs and these leading coefficients, and we're going to answer whether those are positive or negative. So my first one, my leading coefficient is positive. My second one is negative. My third one is positive. And my last one is negative. Now, in order to answer our questions related to our limits, personally, I like to do a little sketch. So I like to imagine a positive sloping line, because remember for odds we think about lines. So a positive sloping line, I'm just going to think to myself, remember this doesn't actually graph a line, I'm thinking to myself this kind of a line. So when I do that, I can understand, looking at this notation, as my x goes to negative infinity, I can see that my y is also going to negative infinity. And as my x is going to positive infinity, I can see that my line is going to positive infinity. Some of you might be good at memorizing. I like to look at a picture. So on my next one, I'm going to think a negative sloping line. So I like to visualize a negative sloping line. That helps me understand that as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to negative infinity. Moving on, I'm going to think of a positive leading coefficient for an even degrees, so in other words, an upward turning parabola. So I'm going to picture that, even though I know, actually this one does turn out to be a parabola. So as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. And lastly, as this one's going to be a downward turning parabola, that's what I'm going to imagine, even though I know it actually looks different. This is what I'm going to picture. So as x goes to negative infinity, y goes to negative infinity. And as x goes to positive infinity, y goes to negative infinity. All right, so we now have taken our old end behavior notation and just rewritten this with our limit notation, and we will still use those in the same way we did in Algebra 2 to also help us create some sketches of graphs.